Hello everyone. Historical data from plant breeding program have been used to evaluate the pattern of performance of the breeding germplasm over the range of observed environments. This data can be used to evaluate genotype performance across regions or locations. However, they often cannot be used to evaluate the genotype performance across years due to the structure of the plant breeding program, where limited common genotypes are tested across the years. The temporal genomic prediction uses appropriate relationship matrices to obtain a complete prediction of all tested genotypes to the past and present environments. This application of temporal genomic prediction is demonstrated using historical data from a CIMMYT wheat breeding program. Each cycle of S wheat is equivalent to a year and tested around 50 genotypes worldwide. Therefore, this dataset is comprised of yield data of 686 genotypes across 25 years from 1,387 trials across 382 worldwide locations. The analysis was done using a two-stage analysis. The first stage analysis was conducted for each trial by fitting the experimental design. The outputs from the first stage were then used in the second stage analysis to obtain the prediction of genotype performance in each of the 25 years. The prediction of genotype performance in each year were obtained using three models. IDID model, where no relationship matrix was fitted. KID model, where a relationship matrix among genotypes based on the pedigree information was fitted. And KFA2 model, where in addition to the relationship matrix among genotypes, a covariance matrix among years based on the factor analysis model was fitted. When no relationship matrix was fitted, we can obtain the prediction of the genotype performances only in the year they were tested. The genotype Bayer table is incomplete. When a relationship matrix among genotype was fitted, the genotype Bayer table is almost complete, except for genotypes that have no relative in these trials. For these genotypes, we can only predict their performance in the year they were tested. When we edit the relationship among years, we can obtain a complete genotype Bayer table. We use pattern analysis for summarizing and visual displaying this genotype Bayer table. Biplots are used to visualize the pattern of the genotype performance across the first 25 S wheat. As an example, the name of 6 release cultivars are included in these biplots. These are biplots from KID model and from KFA2 model. In both biplots, we can predict the yield of these 6 release cultivars in the S wheat where they were not tested. For example, Siri M82, performed quite well in the early S wheat, but not so well in later S wheat. By fitting appropriate relationship matrices among genotypes and among years, we can predict the performance of genotypes in the years they were not tested. This approach enables the evaluation of long-term genotype performances. Because the characteristics of the past years are known, the performances of genotypes in the past are predictors for their performance in similar years in the future. The historical data can provide a validation set to evaluate the accuracy of the prediction model. We can compare the performances of the genotypes in the past with their predicted performances by applying genomic prediction methodology to the present data. Thank you for listening.